Hi there, I'm trying this new format where I focus more on very specific use cases of PCG as a reference for the future, so it will be easier to go back to a specific video. In this video, I'll show you how we can sample points on static meshes. The usual and most used sampling method is sampling points on the landscape, but it's not a silver bullet. Let's say you have hand-placed meshes in your world and you want to sample point on them. The landscape method is not enough. We saw one way of sampling on meshes in the episode 3 of the PCG tutorial with the mushrooms on logs using the mesh sampler, but it requires to specify a specific mesh and can't be generalized to any mesh easily. Therefore, we'll see another method to spawn on any meshes. Let's get started. For this first example, I have hand-placed very simple geometric meshes with a few sphere and a cube. This cube has a tag on it. We'll see later how we can leverage that. And to be able to sample on those meshes, we can use the world ray hit query node. The output of this node is a surface, same data type as the landscape, it's a 2D surface. How come this node outputs a surface? Which surface? Shouldn't it be points? In fact, what the node is outputting is an abstract surface, meaning that it contains the information on how to project point on the surface, but nothing more. No computation is done. You can see it if you try to inspect the node, you get some data, world ray hit data, but no points. So how is this surface defined? Basically, it uses raycasting to project any set of points onto the surface, meaning that we will use the physical world to find a collision to project our points. Not a very accurate example, but I like to imagine if I'm laying a bedsheet on the top of my volume and let it fall. It will envelop the meshes, and the surface is defined by where the bedsheet is laying after it immobilized. As I said, no computation is done, so you need to sample the surface to get points. Since it is a surface, you can use the surface sampler, as we do with the landscape. And if I debug the results, you can see that I have points scattered on the landscape and meshes. There are some options in the world ray hit query node. First, you can remove any landscape hits if you only want to sample on the meshes and not on the landscape. You can also include or exclude tags. I told you before that the cube has a tag cube, so if I only include the tag cube, I get points only on the cube. We can do the opposite. If I exclude the tags, I have points everywhere except my cube. And that's how you can sample stuff using the physical world on hand-placed meshes. Another case is where you want to do the same thing, but sampling on meshes you spawned with PCG or any other system. In this example, I have a very simple graph that just sample points, transform them randomly, and spawn cubes. Same thing that the previous example, we can use the world ray hit query, then add a surface sampler, and then we can spawn some seedlings. So a static mesh spawner, add a new entry, it will be PCG seedlings. But I have nothing there. If I disable the static mesh spawner, you can see that it has sampled only on the landscape. First thing you need to check is the ignore self-hit. Because the meshes are spawned attached to the PCG volume, they behave as self and will be ignored if the option is ticked. But it's not enough. Another very important thing in this situation is the order of execution. Because we have two branches that doesn't depend on each other, first branch spawn the cubes and the second branch query the world and spawn the seedlings, they can be executed in any order. So the query is performed before the cube spawned, hence why we only have seedlings on the landscape. A node depends on another node if you have an edge between those two. All the inputs needs to be computed before evaluating a node. In our case, the surface sampler is evaluated before the static mesh spawner spawns the cubes. So we need to introduce a dependency between those two to make sure the surface sampler gets evaluated after the cubes are spawned. In 5.2, there is no clean way to do it, but there will be in 5.3, so we'll have to get creative. One way to force the dependency is to use the output of the static mesh spawner as the bounding shape for the surface sampler. It just means that the points will need to be within the original cloud to be sampled. It's a crude way to get it working, but we'll see how we can do better after. But right now, we are forcing the surface sampler to wait for the static mesh funnel to finish, and we can see our settings. If you are following this episode while doing it yourself, it might still not work. One last thing is the collision channel. In this example, the collision channel is set to world static, and my collision preset on the cubes is block all. By default, the static mesh spawner uses block all dynamic, meaning that the right collision channel for the world hit query is world dynamic. If we change back to block all, the right collision channel is world static. We'll keep it like this to also sample on the landscape. To see it better, I'll change the parameters on the surface sampler to have way more settings. This crude method works if you want to only sample on the cubes, but if you also want to hit the landscape, it's not enough. It's because we are limiting the surface sampler to our original point cloud. To solve that, we can do a union node between our volume that we will query with get actor data on self and the points from the static mesh spawner, and use that union as the bounding shape, which produces the desired results where the seedlings are on the landscape and on the cubes. Alright, we managed to spawn on hand-placed meshes and on procedurally placed meshes. For our final example, let's try to change the direction of the recasting, because until now we only did from top to bottom. I created this graph where I have cubes floating in the air. The setup is simple. I get the actor data, which is my volume. I do a volume sampler that will give me a 3D grid of points. On this point, I apply some density noise, and I use a density filter between 0.99 to 1 to remove some points. So I had like 4,000 points in the beginning, and then I have 45 in the end. And then I transform them to make them bigger and also offset them from the ground. And finally spawn my cubes with the default block all dynamic collision preset. In that case, I want to do something different and spawn machines below my cube. So I will add a world query node, and I will override default params. Note that those params are hardcoded in 5.2 and they will be overridable in 5.3. We can change the ray direction from going down, -1, to going up, 1. We also need to disable self-hit, and we'll block all dynamics since our cubes are block all dynamic. Then we do some surface sampling. And of course, if we debug, we have nothing, because we'll still have the same problem as before, is that we need to have some dependency between the surface sampler and the static mesh funnel. So you can see that I have the cubes now that are below the other cubes. And so I can add some static mesh spawner, disable the debug, and I will add some trees, like random trees. What's also nice is that you already have the right transform. Because the points are facing down, the meshes are also facing down. There we have 3 different use cases for sampling on meshes using the world query node. It has of course some limitation. As stated earlier, it uses the physics world, so if your mesh doesn't have precise collision, you might see a difference between the sample point and the actual mesh. And it's using recasting, so it's way more expensive than using the surface sampler on the landscape. If you want more precise control on the sampling on the specific mesh, it might be better to use the mesh sampler as we saw in episode 3 of the tutorial. I hope you enjoyed this format, and I'll see you in the next one. In the meantime, have fun with the plugin. Take care.